So I'm going to talk through how you work out the Gini coefficient. So you need to create a graph, and on your graph you need two axes. We've got our x-axis here and our y-axis up here. On our x-axis we have the percentage of the population, and that goes from 0% up to 100%. And on the y-axis here we have the percentage of income. So again, going from 0 to 100%. Now first off, we need to have a think, what would the graph look like in a perfectly equal society? So in a perfectly equal society, 50% of the population would earn 50% of the income. 25% of the population would earn 25% of the income. 75% would earn 75%, and so on. So we'd get a perfectly straight line that went up through the middle. Now that's unrealistic. There aren't very many societies where that's going to happen. So your Gini coefficient is calculated by working out whereabouts a line would fall underneath that hypothetical line. So a given line may look like, for a country, something like this. And that line would have to go underneath the green one. It would never go on top of the green one because it's showing inequality. So here, for example, round about 50% of the population only earn about 20% of the income. And the poorest 80% perhaps own 60% of the income. If I started drawing a line that went above the green line here, I wouldn't be drawing this line correctly, because if I had the 10% of the income, 10% of the population earning 50% of the income, well, they wouldn't be the poorest 10%. So the poorest will always be down this end. So how do I actually work out the coefficient then? Well, let's think of two extreme examples to start off. Imagine I had exactly the same axes. Again, I've got income and population, income and population here. I'm going to draw those two lines, or on those two graphs I'm going to draw those two lines again. So I've got perfect equality there, and I've got perfect equality on that one. But imagine I label these areas up on this graph here as A in there. That's all the area between these two, and B underneath here. That's all the area underneath the line there. So I've got here two hypothetical countries, and I've got two new lines that I'm going to draw on those. One line is going to be perfectly equal. So it's following that line. Okay, that's the 25% earn 25%, 50% earn 50%, 75% earn 75%. In this second example here, nobody is going to earn anything until the very last person in that society, and they own absolutely everything. So in this example up here, the value of A is pretty much 0. And in this example here, the value of B is pretty much 0. Right, so if I told you that the Gini coefficient is calculated by working out the following formula. You look at the size of A and you divide it by A over B. Right, so let's have a look at these two examples on here, my two extremes, perfect equality and complete inequality. So on the perfect equality variation that I have at the top, when A is going towards 0, if I plot this into my Gini coefficient, so here Gini equals A is nearly 0 over 0 plus B. So whatever B is underneath, that's 0 and that's 0, nothing over whatever it is, my Gini coefficient is going to be 0. So in a perfectly equal society, Gini will equal 0. On the other hand here, I've got no one with any money until one last individual earns all the money. So my Gini coefficient here, if I use this equation down here, my A value has got bigger and bigger and bigger. I've dragged this into the corner and there's no B instead this time. So my Gini here is A over A plus 0. So that bit disappears, and whatever A is, a value over the same value is going to be 1. So we can see from these graphs that the further this line comes over towards here, the more inequality we're going to get, and the higher the Gini value will get. And that's why our Gini coefficient goes from 0 all the way up to 1.